Hi everyone. What I have here is a little device I've made up. It's called a 4-bar link system, and it's for lifting. It's a lifting device. You can see that's kind of cool the way that works. So let's go over how it works. Okay. So we'll start at the drive like I usually do. You can see I've made my motor mount here, and a little different than in the past where I used aluminum sheet. This time I used the masonite, and I configured my pieces up to mount the motor like we do with the aluminum, and I glued it all together to make this mount. You can see that I've doubled up on the base feature here. I glued 2 pieces of my masonite together and then glued my vertical piece that's going to hold the motor. And then you look at this guy right here. This is a gusset I put in place just to kind of sure up that I don't get any deflection here when the motor sees any resistance from the mechanism. So that's my little drive system, and you can see here in the drive we'll start off right here with this little brass coupler that's in our kit. If you look at the brass coupler, and it's hard to really kind of see all that, but one side has the spline that accepts the output shaft spline, and the other side is just a straight 1/4-inch bore that accepts our aluminum 1/4-inch diameter stock. So what I've done is I've secured my adapter or coupling to the output shaft using this part. You notice on the sidewall it has a set screw. That set screw mounts it to our axle, which is our aluminum stock, 1/4-inch aluminum bar stock, round stock. One little tip about when you're using a set screw to mount anything, they have a tendency to back off, especially when you're mounting it on a round surface such as this aluminum. You want to put a flat on the aluminum to accept the flat bottom of the set screw. If not, when it sees torque, it just works itself loose, and that's a common problem with set screws. Not the best idea, but this is what we have, and if used properly, they're actually pretty good. So there's my drive, my motor, my output shaft, my adapter coupling, and my axle. Now you'll notice that on my axle I have a gear, and that gear is going to drive the gear that it's adjacent to. And you can see a gear stack here. All 4 of these gears are the same, so it's basically a 1-to-1 ratio. You can change that to fit your design if you choose this type of a thing, by changing the diameter of your gears. If you're going to use a gear train or a gear stack like this, the real important thing to look at or be considerate of is the centers of each one of these pivot points, the axle that drives the gears. They have to be equally spaced based on the pitch diameter of the gear. If they're too far apart from each other, obviously they're either not going to drive or they're going to slip very easily. And if they're too close together, they're going to bind up and they won't spin, and that all that extra force is going to be translated back into the motor, and you know, that's bad condition. So you need to know the pitch diameter of these and then space them accordingly. And like all our other little gizmos that we put together, I'm using bushings on this side right here. You can see the bushing. The bushing is into my vertical support, and it acts as a friction reducer for my axle as that spins. There's another bushing in this side here, here, and here. On this side I didn't use bushings, although it looks like I did, but these are actually the little nylon washers, just so I replicate the spacing of the bushing head on the flange here. I replicate that distance right here, so I have symmetry between these gears here. And I'll explain what these gears are actually doing. as I go forward. So if we're driving this gear has to be fixed to the shaft. And on a previous video, if you watched them, I showed you how to put a 1/16 roll pin through the hub of the gear, and the hub of the gear is this smaller diameter that I'm pointing to right here, not the ID but the actual hub. So the pin goes right through the hub, the aluminum, and out the other side of the hub, and you put the pin in. You can actually see the pin right down inside here, that little nub that's sticking out, and you can see the hole goes right through. So this is completely pinned. I did that to the drive gear, and the fact that this axle assembly is going to be driven because that holds one of my bars that are going to be lifting. Actually holds two of my bars. So this actually, it's going to turn this gear here, which in turn is going to turn the axle. So I need my arms to be mounted to that axle. So what I did, because it's in our kit, I just used 4 of these gears right here and here. And what I did was I slid that on the aluminum, and then I pinned this gear to the shaft so that I had a mounting surface for my bar, like you see. And I've used nothing more than the self-tapping screws. They're in our kit in the little bag with all the horns and such. I use those to go through my tongue depressors that I glued 2 together to give me some strength. These have become really handy for me. I love using those. And you can see how the screws go through, self-tapped into the gear, acting as my arm adapter. You can see the screw heads, the end of the screws sticking right through the gear right there. And I did that 4 times. Now all my gears that are being driven here are affixed to the axle, except for this one right here, because this one's doing nothing more than transferring the radial motion from this gear through this gear and into this one here. So this one can float free on the axle because there's no need for a drive on the outside, and so that can float free. That's called an idler gear usually. So this little assembly right up here and this one are exactly the same, so you would duplicate that. So that's pretty cool. I used my 1/4-inch thick plywood. It's pretty stable material, pretty strong. I used just the angle aluminum, the 1-inch angle aluminum, and made these little mounting brackets to support to my base. The arms, I used the popsicle sticks, like I said, and to join them together out in this area, I used an axle, the 1/4-inch aluminum going through. I made this little aluminum bracket that you can see, just the 4 ears lit up, bushings through the bracket so that I don't have aluminum on aluminum. That's a bad condition for friction and galling. And then I used the little push nuts to retain my assembly onto my bars in 4 locations. So as important as it is these centers to be the same, equally spaced based on the pitch diameter of your gears, this distance right here, from here to this point, is also very important because they have to work in unison. All these right here, all the locations. So you need to take care in making sure that these are in the same distance apart, center to center. That's important. So that's my little 4-bar mechanism, and I'll show you something I did here on the end. This plate here, this is acting as kind of a receiver for whatever we're going to use this particular device for, whether it's hooking and lifting or just lifting something up, jacks, or lifting scissors, or whatever it is. What I've done is I've made like this modular plate for the face. As I made this aluminum piece, I determined that I wanted it to be versatile to the point where I put the screw heads through here, creating studs, mounting studs. So now I can make whatever it is this device is going to perform for me, whether, like I said, it's shoveling or hooking or whatever. And if I decide to change course, I don't have to disassemble my entire device to get everything apart, because whatever I'm actuating is actually separate from the wings of this device. For instance, I made this little shovel mechanism that I can just slide on that whole pattern. And I put my nuts on. I'm only going to put one nut on just to save a little bit of time. But you can see if I put all 4 of my nuts on there, you can see if I put all 4 nuts on there, I have the adapter plate and this mechanism can work. And if I want to change this idea or alter this in any way, it's just a matter of taking these 4 screws off, my alterations, and then putting it back on. So that's kind of a neat feature. So let's see it in action. Actually, let's see how one of these guys works. So I'm going to hook up my motor to my number 6 position on my pins on my receiver, and then I'm going to hook up my battery. Remember, the negative side, the black wire, always faces outbound of your receiver. Let's see what happens here. Turn the power on. Turn this power on. And I'll use the number 6 channel here. Get my hand out of the way, and you can see how that actually works. Get a view of that. Of course, my video is going to freeze on me today, but you can see that motion. And you can see the importance of how the gears are meshing. Let me flip this over a bit. How the gears are meshing. If we didn't have a perfect scenario of the spacing based on the pitch diameters there, these wouldn't be able to operate at all. So it's actually a fun little device. Aside from taking care as to the hole locations, relatively easy device to make up. Start with a good foundation, a good solid mounting surface for your motors, and work from there. That's kind of fun. Alright, so that's our 4-bar lift stem. Hopefully that helped.